Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 85 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 84. So I must begin by asking you, were you successful? If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, hopefully most of you guys got this, but what we've been working with in the last few lessons is becoming comfortable using timers and interrupts. And what your homework assignment was to create a button-controlled binary counter where every time you press the button, it would increment the binary number displayed on 4 LEDs. And the kicker was that you couldn't do anything in the main while loop or the main part of your Python program. Everything had to be done with interrupts, okay? So I'm going to show you my solution, and I'm eager to see if you guys took a similar approach to this or if maybe you took a different approach, but I think there's probably more than one way to do it. So I'm going to jump in and show you my way, but let me start by coming over here. I will need to get out of your way. All right, there we are. And what you can see is I have 4 red LEDs, and then I have a red button. Please ignore this green button. Pretend it's not there. This will be for next week's homework assignment that I'll show you at the end of this lesson. So for today's homework, you have a red button and you have 4 red LEDs. The least significant LED is connected to GPIO pin 16. Then this one is GPIO pin 17. Pin 18 and pin 19. Each one of these short legs of the LED goes through a 220 ohm resistor to the ground rail. Okay, and then the long leg of the LEDs goes to the respective GPIO pins. So we have GPIO pin 16, 17, 18, and 19. Now on this push button, we are going to configure it with the internal pull down resistors. So the left leg of the button, since we're using a pull down resistor, is connected to the positive voltage, which comes from physical pin over here. It is the 1, 2, 3, fourth one over from the bottom right, and that is your 3.3 volts. And then we have the we've got the ground rail here. If we start in the corner 1, 2 over, and the 3.3 volts is 1, 2, 3, 4, the 5th one over. So let's try that. 1, 2, 3, 4, 5th one over, and the 1, 2, the 3rd one over is the ground. You can look at your little key card. I don't have mine really. Oh, here it is. Okay, let me stop this amateur hour. It is the ground is physical pin 38 and the 3.3 volts is physical pin 36 there. Should have had my little card in front of me to begin with. Okay, then on the on the button, we have the button connected to the power rail, the left leg of the button connected to the power rail, and the right leg of the button, we come up to GPIO pin 20. GPIO pin 20, which is actually down here. GPIO pin 20 down here. All right, so that is how we have the red button set up. So now the first thing that we're going to have to do in order to get this thing to work is we are going to have to establish a debounce switch so that when we press that red button, we get a very distinct and non-bouncy signal so that when we press the button one time, what happens? We increment the binary counter one time. But let me talk to you a little bit before we jump in and start coding, because we'll probably forget this and not get around to it. What strategy am I using to toggle? What strategy am I using to toggle these LEDs? Okay, what strategy am I using to toggle these LEDs? To explain that, I've gone ahead and I've drawn up counting from 0 to 15 using the 4 LEDs. And what I want you to see is if I want to increment the number 1 bit each time I press that button, this is what it would look like as you go from 0 to 15. Now I could go in at every single button push, I could write the 4 LEDs, but I want to think of it in a way that lets me do it with fewer lines of code, and therefore I want to think about the 4 LEDs. I have LED that is worth 1, and that is the least significant bit. Then I have the LED that is worth 2, which is the next one over. Then the third LED is worth what? The third LED is worth 4, and the fourth LED is worth 8. And so I've kind of labeled my LEDs based on their value. Okay, so what's the easy one? The easy one is LED 1. What do we do on every button push? On every button push, we're going to toggle. Okay? And on LED 2, every second button push will toggle. Do you see that? You see, if I just look at the second LED, I go off, off, on, off, off, on. So do you see that it's like every second button push we toggle? For LED 1, we toggle every button push. Now, if you look over here at LED 4, what do you see? It's on 1, 2, 3, 4. It's off 1, 2, 3, 4. It's on 1, 2, 3, 4. It's off 1, 2, 3, 4. So we toggle what? Every fourth button. Okay, and this should be button here, or button push. Now, what does LED 8 do? It's off 1, 2, 3, 4, 5, 6, 7, 8, and it's on 1, 2, 3, 4, 5, 6, 7, 8. Off 8 and on 8. So what does it do? It toggles every 8th button push. Okay. So that's conceptually very easy to see. Now, programmatically, what do we do? Well, on LED 1, it's just toggle every time. Okay, so every time there's a button push, I toggle. Now, in LED 2, every other one, well, how could we do that? We could use the mod. So I take the count of the button push and I mod it by 2. And then if there is a remainder, you guys tell me, what will I do? I will toggle. Okay, if there is a remainder, I will toggle. So let's think here, right here, if I am at 1 and I divide by 2, I get 0 with a remainder of 1, and I want to what? I want to toggle. Okay, if I am at 0, 1, 2, and I divide by 2, the remainder is 0, I don't toggle. Okay, if I'm now here at 0, 1, 2, 3, I'm here at 3, and I divide by 2, there will be a remainder, I toggle. And so count mod 2, if there is a remainder, then I toggle. And by the same kind of argument, this would be the count. Man, I am just not being very neat here today, am I? Here I would say for the LED 4, count mod what? 4. And if there is a remainder, then I toggle. And then this would be what? Count mod 8. And if there count mod 8, if there is a remainder, then I toggle. Okay, stop and look at this diagram, and I think it'll make sense what we're doing. But if you understand this, it makes the code a whole lot easier, because remember, we're doing this with the interrupt. We're not doing this with the main part of the program. Okay, with all that being said, let's jump over here. And I do think that we are ready now to begin coding. So let me jump over here. And let's just jump in. And first of all, we're going to have to from machine import pin, because we're using the pins. We're going to import time. I really don't know if I use time or not. Then we're going to set up the butt pin. I said the butt pin was what? GPIO pin 20. All right, then I had the LED. I have red pin 1. That's going to be that least significant bit. That is going to be 16. Then I have red pin worth 2 is going to be 17, like that. Then I have red pin 4, which is going to be equal to 18. And then red pin worth 8, which is going to be equal to pin 19. So I sort of give it the place value to help me as I'm going through programming, remembering what's what. Now, if we're going to do this, we need to remember the number of button presses. And so I'm going to initialize that press, the number of times the button's been pressed, to 0. Okay, now we're going to set things up like we did earlier for those interrupts. And so last week's lesson, we talked about this T up and this T down. So T up, the time that the up press happens, is going to be time dot ticks. We're going to do this in milliseconds and open close. And then T down is equal to time dot ticks underscore milliseconds. Like that. Okay. Now, why are we doing this? Because when we get down into that function, the first time through, it might need to have values. And so we're going to go ahead and seed these values in just so the program doesn't crash the first time through the loop. Then similarly, we need the but state old. That's what was last time through the loop. Was the button up or was the button down? Okay, last time through the loop, was the button up or was the button down? And we are going to keep track of that in but state old. So we've got to, again, seed that with a value. But state itself will read the first time in the program, but this we've got to put a value in so it doesn't crash. And so we're going to start it at 0, just saying when we start, the button hasn't been pressed now, and certainly it hadn't been pressed the time before. Okay, so we've got the uptick, we've got the downtick, and we've got the but state old. Now I'm going to define a function int switch, and this is going to be what? This is going to be our handler function. This is going to be our handler function. And so I'm going to come up here, and I've got to pass it a parameter, so I'll just pass it pin just so that that's not empty. There is something there. Now I need to make global my variables that I share with the outside program. And so what are those? I think that is going to be what we just set up. We are going to say global, and that's going to be the press, how many times the button's been pressed, T up, which we got from above, and then T down, which we're going to get from above, and then but state old, like that. And so it should be these 1, 2, 3, 4 things that we initialized up here are what we're going to make as a global variable. Okay. Now, what we have to do is we have to know that how do we get, I think it would be good if I came down here and went ahead and set up, I'll finish defining this function later, but if we set up the interrupts first, then it's going to make more sense when we go through and do the callback function. And so I need to set up a watch button, and that is going to be pin. And which pin? The but pin. The but pin is going to be a pin.in, its input. And then what do we need to do? Pin.pull down. So we're going to activate that pull down resistor, right? I told you we were using the internal pull down resistor. So this is just setting up the button pin. Okay, now what we're going to need to do is we are going to need to set up the interrupt. So where are we going to set it up? On watch button, like that. And we need to say we're going to set up an interrupt request like that. IRQ would probably work a little better. And then what are we going to do? The trigger. How do we want to trigger? Well, from last week we learned that we want to do a pin.IRQ underscore rising like that, or pin.IRQ underscore falling, right? Because we want to look when it goes up and we want to look when it goes down, and then we want to measure that pulse width, or from when it goes down to when it goes up, measure that time, and that way we only consider things where it's a certain length, and that way we filter out all of that switch bouncing that causes us so much problems that we talked about ad nauseum last week. So I don't need to go through all of that again this week. Okay, but what I do need to do is I need to tell it what is my handler. What do I want to do when there's an interrupt? I'm going to go to that interrupt switch like that. That's that function we're defining up there. Okay. And I'm glad to see that didn't go behind my head. I know you guys get upset when the coding goes off behind me, so I try to be mindful of that. Okay, let's go ahead and set up our LEDs while we're at it. And so I'm just going to say red LED 1 is equal to pin, and then what is it? The red pin worth 1, comma, that's going to be a pin dot out like that. And then we're just going to copy that and paste it 3 times, copy, and then Control V, Control V, Control V. So red LED 1, red pin 1, red LED 2 is red pin 2. Then the LED worth 4 is not 3, 4 is worth 4, and the red LED pin 8 is worth 8, like that. Does that make sense? Okay, we've got all those things set up. Let's also just set up our bookkeeping here. We're going to say try, right? We want the keyboard interrupt, so we're going to do a try except. So I'm going to say try, and then while true, when is true, true, true is always true. We've created an infinite loop. What do we want to do? Absolutely nothing. Everything's got to be done up with the interrupt and the interrupt handler, nothing in the main Python program. Then we want to keep doing that until we get an except on a keyboard interrupt like that. Okay, keyboard interrupt. And then we want to do red LED 1 dot off. We want to, if we Control C out of the program, we want to turn all the LEDs off. And so then we're just going to kind of take advantage of this code, and then we are going to Control V, and then we are going to Control V, and then we are going to Control V, and this is red LED 1, 2, 4, 8. Do you notice how if we name our variables well, how quickly things go when we actually start coding? Okay, so let's just run that. This isn't going to do anything, but let's make sure. Ooh, line 19, we already have an error. Okay, so what is that error? Pin has IRQ rising. What did I do wrong with IRQ rising? All caps. I love to check my code as I go. Like I say, okay, 19, pin. I'm really struggling with my capitalization, aren't I? Okay. Ha! That pesky line 19, it's been fixed now. Okay, now I'm just going to Control C and I get out of the program. That is good. Okay, now what we want to do is we now want to kind of build into the main part of this we did last week, and it's going to really be kind of the same thing, and that is debouncing the switch. And so first of all, I want to look at the button state. Like I ended up in this routine because the button was either pressed or the button was released. All right, either button was pressed or released, and that's how I got here. But now I got to kind of figure out how I got here. So if I say I got to read the button, so I got to say the but state is equal to the watch button dot value. Okay, so I got here somehow. If it's a 1, then what does that mean? That means the button has been pressed. Okay, the button went from up to down. Okay, if I'm reading a 0 here, that means the button went from down to up, and that's what got me here. Okay, hopefully that makes sense. So now, if the but state equal 1, then what does that mean? If the button state now equals 1, that means I went from not pressed to pressed, and therefore the button went down. Okay, and that is going to be equal to time.ticks underscore milliseconds. Okay, like that. So the button was pressed down, and that plus should be equal. Doesn't count as an error if you catch it before you run it. So if but state equal 1, that means the button has been pressed. The button has been pressed, and therefore the time down, right, the time that the button pressed down is going to be equal to this. All right. Now, what's the other case? If the but state now equal 0, that means the button is presently up, and I'm in this routine, which means it triggered, which means I went from down to up. Okay, so if but state equal 0, then that means the button just went up. So T up is time.ticks underscore milliseconds, like that. Okay, so now I have the T down time and the T up time. So what is the business part of whether this thing we should toggle or not? Okay, if but state old equal 0, that means last time the button was up, okay, and but state this time equal 1. So I went from the button up to the button down. And now I want to filter out. Now I want to filter out any of that jitter. So I'm only going to count it as a real pulse if the T down minus the T up, if that is greater than 50 milliseconds. And if it's not, I'll live dangerously, I'll say 25 milliseconds. And if it's not greater than 25 milliseconds, I will assume that that was just noise, that was just bounce. Now you could say T down minus T up. Okay, you could do that. That would be the time when it was pressed down to the time that it was pressed up. Or you could do it this way. And what I'm going to do is I'm going to say time.ticks difference of what T down and T up. So that's from when it went down. You know, I got T down when it went down, and then I subtract from that when it went up. And then that will be the amount of time that it was actually down. Okay. And if that is greater than 25 milliseconds, then we are going to say that we have a winner. Okay, now I'm just going to sort of see if this works. Let's see, I'm just going to say print trigger and then print press, like that. Okay, and now I've got to do a little bit of bookkeeping here now, that, you know, to update everything. So what would happen here then is, outside of those if statements, what I need to do is say but state old equal but state, like that. Okay, so now I just want to see if this thing triggers when I press the button. So let me come over here. Let's just run this, see if we got any other problems in here. Okay, looks like it's running. So now I'm going to come over here and I get a trigger 0, trigger 0, trigger 0. Okay, well, it's triggering, but what did I not do? I didn't increment the press. Okay, so I need to come here, and if I get in this, I need to increment press equal press plus 1, like that. So now let's run this, and let's just see if this will count my presses. All right, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that seems to be working very, very well. And so it's measuring from the time it was down to when it comes up. So it actually triggers on the up. I mean, it triggers on the down. Okay, so I go like that, and it's triggering on the down. Okay, so if but state is 1, I'm just going to think about this. If but state is 1, that means it has been pressed, and it has been pressed down. Okay, so this is working as we would expect it to. All right, so now what we have to do is we actually have to do the toggle inside this if statement, because if I get inside of this if statement, that means that I have gotten a bona fide switch. All right, so now let's see what I would want to do. Well, every time red LED 1, I want to toggle. Every time I want to toggle, because every time I get a valid switch, I want to toggle that least significant LED. So every time I do that. Now, if press mod 2 equals 0, that means if I don't have a remainder, then I want to toggle. Okay, if I don't have a remainder, then I want to toggle. All right, so this would then be red LED 2 dot toggle. Okay, if I don't have a remainder, then I want to toggle. Now, same thing, if press mod 4 equal 0, then what do I want to do? I want a red LED 4 dot toggle, like that. And then if press mod 8 equal 0, then what do I want to do? Red LED 8 dot toggle, like that. Okay, now could it really be that easy? Could it really be that easy? Let's see. I'm going to control C out of this to exit cleanly. Okay, and that did exit cleanly. So now let's run this thing. Okay, no errors. Now all eyes on the LED. 1. Didn't toggle the second time. Let's see what I got wrong here. Okay, 1. Okay, somehow on that second LED, I have a little bit of an issue. So if press mod 2 equal 0, then red LED 2 toggle. If press, that sure as heck looks right, doesn't it? That sure as heck looks right. Trigger 1. So the trigger 2 worked. But let's see, I must have an error in here somewhere. Press is press plus 1. Okay. Let's, red LED is pin 17. Do you see my error here? Hopefully you guys caught that. That one was frightening me a little bit. I didn't edit that to be pin 2, and therefore I wasn't talking to that. So let's try again. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom, and we wrap around back to 0. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and back to 0. Okay, guys, I think this is pretty cool. And do you see what the assignment was? I did everything without using the main while loop. I didn't use a time.sleep anywhere. And what did I do? I did it all inside of this interrupt handler. And then I also think this was kind of a clever way. I think that this was probably a clever way to, sort of do the counting pretty quickly. Okay, guys, let's see. Let's take a look at this, and hopefully this was a fun project. I'll be interested to see what your solutions were. But let me go ahead and let me give you the homework assignment for next week, and that is to add the magic green button. What does the magic green button do? It is a countdown. So if I go 1, 2, and then that goes 1, 0, and I go 1, 2, 3, 4, and then it goes back to 3, 2, 1. And also, I want you to watch this. If I'm at all 0 and I count down, it goes back to 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, boom. And also notice how perfectly those switches are debounced. And so that is your homework for next week. Your homework for next week is to add that down counter so that using only interrupts, you can count up or count down using 2 buttons. And this, again, what I'm trying to do is I'm just trying to get you comfortable using these interrupts because they're very, very powerful. And then we leave the main part of the program free for more important things. We're not taking the bulk of that processor, the bulk of our core that we're using to sit and just try to be, try to do the management of the buttons. That's all offloaded to the interrupts. And then inside the main program, we can focus on whatever our main function is going to be. Okay, guys, I hope you are enjoying taking this class as much as I am making it. As always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and encouragement that keeps this great content coming. You can also help me by giving me a thumbs up or leaving a comment down below. If you haven't already, make sure you subscribe to the channel. When you do, ring that bell so that you'll get notifications when future lessons drop. And most importantly, share this video with other people because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.